again, everyone. So, now we get to some more interesting types of exponential functions because now we're going to learn about how I can sort of transform them. So, this is probably the most different from the functions we learned about before, but it still kind of behaves in a similar way. So, a general form of exponential functions can go like this: f of x equals a times b to the x minus h power plus k. And we still kind of use h and k in the ways we used them before, where h represents a horizontal shift, and where a positive k value represents going to the left, and a negative means we're going to shift to the right. K is our vertical shift, and positive means we go up, negative means we go down. If A is negative, we're still reflecting across the x-axis. So nothing new there. If the absolute value of A is greater than 1, we're stretching the graph. And if it's between 0 and 1, we're compressing. So all the same rules apply. But we'll get into how this works exactly in a bit. Let's just go over some simple problems right now. How to identify the behaviors of our functions. So we want to identify the parent function and describe how we're transforming it. So in part A, our parent function, as you can remember, is always f of x equals b to the x power. That's our parent function. So in this case, for problem 1, our b value is going to be 3. Because b is the value that's being raised to the x power. And the only thing we have altered in this new function is we're adding 5, So that's part A. Part B, since we're adding 5 is a k value since it's on the outside, it means we're going up 5. For part 2, the parent function is f of x equals 1/4 x. That's it. Because you want to keep it in that same b to the x form. Our b is 1/4, since that's the value being raised to the power. And we're not going to include a -1. But for part B, that's what we'll be looking at. So, how is the function in part 2 different from the parent function? Well, since it has an a value of 2, that means we're going to vertically stretch by a factor of 2. And since we have x minus 1, that's kind of like our h value. So that means technically like our h is 1, which implies we're going to move to the right 1 space. This got to be careful since it's the same trick. Your h is just, think of it as the opposite sign of what it looks like. So these are some basic ones. We got a couple more. For 3, our parent function is f of x equals 4/3 x. And we will be transforming it. We will be, first thing we notice is this negative in the front. That means we're going to reflect it. Reflect over x-axis. We have plus 2 in our exponent, so that means we're going to go to the left 2. And we have plus 7, so we're going to go up 7. So really not that bad as long as you can keep track of everything. It's a lot like the previous function transformations. So in part 4, our parent function f of x is 5 to the x power. And the transformations, we will be vertically compressing by a factor of 1/2. Go to the right 4. And then down 2. So this is just us identifying how these functions will be transformed. In the next couple problems, we'll actually be graphing some of these transformations. So stay tuned for that.